Hello all. Today we'll discuss about how to make a propeller display. Propeller displays generally works on a concept of POV, means persistence of vision. Okay, means this is the project which consists of 8 LEDs in a string in an array manner. These are the 8 LEDs connected in a port of controller. Okay, and I have used a 30 centimeter scale to mount a LEDs display on it, and the other end the microcontroller with regulator and a serial port and Bluetooth. Okay, this is the wheel which I have used to connect the motor shaft of 1000 rpm motor shaft to the my scale. You can see the other view of the side view of this setup. I have used a couple of nut bolts to mount it properly because the motor rotates at 1000 rpm, so we should have a tight setup. Okay. These are few views in different angles. Okay, so let's go in depth to know how to build a proper propeller display. The main key factor behind to make a proper propeller display is the delay concept. Means how much delay you need to glow a LED turn on and turn off. Okay, I have written a small text formulas in the text pad, so you can see that. I'll zoom it more. Okay, now it's visible. The proper delay is very much essential to display the LED a proper letters on when the propeller clock is rotating. Otherwise we don't get a proper letters on it. Okay, let's consider that our motor, the what we are using, it's a 1000 rpm. It's better to use a 1000 rpm motor or above one, because if you are using something below it, you don't get a proper thing letters on it. If I'm using a motor of speed of 1000 rpm, my time for one revolution will be 60 seconds. 1 minute rpm means rotations per minute. 1 minute consists of 60 seconds, means 60 divided by 1000, means each revolution is taking 60 milliseconds. The radius of my circle is 22 centimeters. Like you can see that I have used a scale of 30 centimeters, and you need the radius mean the center LED, the distance between center LED to the center of motor shaft, not the whole thing. The distance between center LED to the center of shaft. Okay, this is the middle LED to the center of shaft. This calculation should be pretty much closer to get accurate values, and I have considered it as a 22.5 centimeters. Then the perimeter of cycle is 2 pi r, means 2 into 3.14 into 22.5, means the result I am getting 414.37 centimeters is the perimeter of my cycle. Okay, let's consider the I have taken the width of each column of LED. To display later, I am considering a 6 columns. This is column 1, 2, 3, 4, 5, 6. The 0 indicates the glow of LED. You can here see that this is the letter which is in a shape of A. Okay, this is a one column, this is a one column, this is a other column. So total I have 6 columns, means I am using a 6 column to display each letter. Okay, here you can see the shape of A is formed by zeros. Because I am using the active low signal, I am considering as 0 to glow my LED. Okay, Let's go to the text again. So the width of each column, the column what we have discussed right here, is the column, each column. So the width of each column is I am considering as a 0.5 centimeters, means okay. The total number of columns in my perimeter will be perimeter in my cycle will be perimeter divided by 0.5 centimeters, that is 282 columns, means I can have 282 columns in my cycle. Okay, so 282 columns I am having for the 60 milliseconds. So one column will be take as a 260 milliseconds divided by the 282 columns, that what I am getting 212.20 microseconds. Okay, as I already explained, I am using the 6 columns to display each LED, each letter. So my total time to display each letter will be 6 into the 6 the time for the one column, that is 212.20 microseconds, means here this is the final delay value what I want to achieve it, that is 1273.23 milliseconds, means 1273.23 milliseconds is the accurate delay value which I need to generate to get a proper display of letters. Okay, I have achieved this accurate delay by using a timer timer 0. So I built this project in the 80 by using the 8051 microcontroller and the code written in an embedded C. Okay, so this is the code. So this is the function which produce the accurate delay of 2.1, that is 1273.23 milliseconds, means 1.27323 milliseconds. Okay, sorry. 1273.23 microseconds equal to 1.27323 milliseconds. Okay. So since I am using a so this is how the proper delay can be achieved using a timer. Most of the programs will have they using some for loop functions to get some delay, but that is not a proper delay value, so you don't get a good letters on it on your display. So I recommend you to use a timer to generate a proper delay. So this is how we need to calculate the proper delay. Motor speed, revolutions, radius, perimeter, width, all these things we need to consider to get an accurate delay. So once you achieve the proper delay, then you can display anything what you wish. Let's go forward. Since the length of each letter is, I am considering 6 columns into 0.5 centimeter, 3 centimeters. So 3 centimeters in my perimeter I am occupying for the display each letter. Then the total number of letters I can display is 47 letters I can display in my circuit. Okay. So now we achieved the, since proper delay is achieved by using a proper timer function. So let's go forward. I'll display the first prototype what I am using built to display a letter A. You can see that the letter A, I just write in a while loop to display the letter A to get my proper delay function. So now I am enough confident that my delay function is working fine since I am able to see the letter clearly. Okay. Now the other question is, how can I get the stability? Because without stability, if I am writing something in a while loop, it's randomly displaying throughout the circle. So you need to achieve the stability by using a interrupt method. Means something should be interrupted to the controller to know the to tell the controller to where it has to be start. So if you are not using an interrupt method, and if you are displaying through in a you are writing your entire code in a while loop, then this is how it will be. I saw a video without an interrupt. Okay, so let's go in my code till the video comes. This is the I started with defining the proper delay value. Then I created a function called display, which as a switch condition. The switch as a case A, case B, case C means till A to Z and 0 to 1 all the letters and numbers I have defined in a different cases, like case A, case B, case C, etc. And each case I am giving the LED pattern. LED is I defined a port 2 as my LED port 2 as LED. So I am giving a X value a pattern to display the particular letter. So let's consider the how to make a pattern to display letter A. I have created an Excel sheet. Here you can see that okay. So 0 0 0 0 okay 1. So wherever you want to, if you want to get a proper letter, then this is like to display the letter A. First you need to give the value 80, 77, 77, 77, 77, 80 to display the letter B. So this is what in my function 80, 77, 77, 77, and the last letter was FF, means it's used to turn on all the columns, all the lights, since it is working on active low. So let's go to the how to write what is the X value to display the letter B. This is the B, right? Okay, you can see that the pattern of B. See? Okay, so to display the letter B, this is the X value you need to put in your port of LED which have connected. So this is what we did. First 0 0, then 6E, 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 and 9 1. So let's go to the how to display the letter C in X value. So this is the most important to get a proper value. What is X value? You need to send to your port which is connected to the LEDs to get a proper image of your letters. Okay. So this is the letter C. To display the letter C, first you want to pass the X value 81 to your port, then a delay, then 7E, then delay, then 7E, then delay, then 7E, then delay, then 7E, then delay, then 7E, and then delay. Then switch off the all the LEDs to give a one column space between two letters. That is what we did in our code. 00 81 delay, 7E delay, delay, 7E delay, 7E delay, 7E delay. So this is how I display the letter C using these commands, and the final state may indicate switch off the all the LEDs for this delay time to give the one column space between two letters. Otherwise the letters will be overlapped with each other and it is very difficult to read. I wrote this code for all the A to Z letters and 0 to 1. I did a serial interrupt method just to send any our custom data apart from the data which is hard coded in code. Then whatever the data you want to send custom data through Bluetooth, you can use a smartphone to send, or any phone which has a Bluetooth medium phone or PC, and you can send it your message to it and you can display on it. So this works on interrupt method. Okay, let's go to the main program. The main program completely wow, nothing will be there. It's as an interrupt service routine. External interrupt service routine is enabled. Okay, so whenever an interrupts comes whenever the infrared beams are the comes in a straight line. Infrared transmitter and receiver comes straight line with each other. Let's show the what is the infrared. Okay, so this is what I'm using infrared technology to get a stability in my letters, to display it in a proper order and proper pattern and a proper position. If you are not using a proper interrupt method, then I will show you how the display will be there if you are writing your code in a while loop. Here you can see that I wrote some code, hard coded some letters in my code, and all the letters are they overlapped with each other without any starting and ending order, starting position or ending position. So this makes user very difficult to read what is the exact message. To avoid this, it's better to use an interrupt to decide the starting position of message. So you can see that it's very difficult to read it since the letters are overlapping with each other, and I wrote complete code in a while loop. So I changed my code, and instead of while loop I wrote a code in the interrupt method, external interrupt, which can be generated by the infrared rays when it comes in a straight line with each other. I'll show you the. So here this LED, you can see that this is an infrared transmitter, and this black color LED is an infrared receiver. When this infrared transmitter and infrared receiver comes in a straight line with each other, then the position of my that is the starting position of my text or message will be started. So in this way I'll get a proper order without overlapping the letters with each other, and the user can easily read the what is the message on the propeller. Let's see with installing the proper infrared how the message will be on the propeller. Yeah, sorry, this is the final. You can see that. You can clearly see that welcome to. It is a particular order is displayed, and then I'm displaying some stars. STS EIT Hyderabad. Since I got the proper stability in my display, I'm just left shifting, right shifting each frame. So I have a control to do whatever the modification wherever I need to move my letter. Since I have a proper stability, 20 years of whatever the message recognition. So I recommend you to use a proper infrared or whatever a interrupt can be generated, so which can decide the position of the your starting position of your message. So I have you to test my program. I created a protest model. This is a protest model which have a pulse generator to connected to the external interrupt pin of controller to give the interrupts for every 60 milliseconds. Since as we discussed, the each rotation will take for 1000 rpm motor, each rotation will be 60 milliseconds. So I need to give, then you can assume that interrupt will become for the 60 milliseconds. Fine. That's why I connected a pulse generator to give a 60 interrupt for every 60 milliseconds, and you can see the patterns of LED. But the real pattern can be displayed only if it is rotating. For the time being, to just for the testing purpose, the code is built properly or not, we can use this protest model to check our code. You can see that the LEDs are blinking very fastly. You can't see the pattern of complete letter because it's in static stage running. I have integrated a Bluetooth technology to this propeller display. You can whatever the custom message can be sent to this model propeller display in order to show your own names or anything whatever you want to display, something which is not present in your code. Let's I want to display my name Guru, and end with slash check propeller. Means check propeller message will be displayed on your phone, which then you can see that the display will be given the respected message which were sent through the your mobile. I have created some other videos to display very lengthy messages. You can see that see since I use the interrupt method to display the letters on my propeller, you can see accurate position of the display. So it is very easy to read the user to whatever you want to display it. Right? I'm using some names Rafikant, Anji, Guru, etc. Thanks for your watching this video. So while building the propeller display, I advise all the newbies get a proper delay with using a timer, get a stability by using a interrupt method. It can be infrared or it can be all sensor with a magnet or anything. I prefer these two methods and make a custom Excel sheet as per as shown this. So in order to display your custom messages, whatever the text you want to display, okay, these three things you need to be keep in mind while building a proper propeller display. Thanks for watching this video. If you have any queries, you can post here and I'll get back to you. Thank you very much. Have a nice day. Bye bye.